The deviation from a straight line of the descending passage, which is cut deep into the pyramid into the bedrock 105.3 meters long, is only 6.4 millimeters. To achieve this accuracy, the ancients had to possess some appropriate measuring instruments as well as the knowledge of metrology, the study of measurement, and wielding the measuring instruments. The accuracy achieved by the builders of the Great Pyramid is equal to modern standards.
I'm Andras Sabo, an independent researcher of prehistoric culture. Some years ago, I've decided to move to Egypt. I've been motivated by only one question. Who was the mysterious ancient civilization who built the pyramids and the temples on this sacred land? Subscribe to my channel to visit a lot of unique places and to get advice how to have your own great adventure in Egypt. Let's search for the answers together.
Для того, чтобы воплотить идею и спроектировать сооружение, нужно обладать навыками в области математики. В книге о всеобщей истории архитектуры ученые утверждают, что, сравнивая отдельные части египетских зданий, можно установить между их размерами самые простые соотношения, например, 1 к 2 или 3 к 5.
The system of proportions in the Egyptian architecture is based on a square and its derivatives by diagonals. According to Plutarch, the main role here is played by the so-called Egyptian triangle with the aspect ratio of 3 to 4 to 5. It is believed that the ancient builders were able to achieve the right angle during the pyramid construction with the help of a rope. Although, seeing the perfection they had achieved, it is hard to believe that. The ancients used geometric knowledge to design both individual structures and entire complexes. The complex of 3 great pyramids on the Giza Plateau, where scientists and enthusiasts identified the placement pattern for the pyramids and other structures, can serve as an example. The idea of Egyptian sciences of the ancient kingdom period, mathematics included, relying on deep knowledge far ahead of their time, is gaining more and more popularity.
Что именно знали древние о математике, нам известно из сохранившихся источников, таких как папирус Ринда, Московский математический папирус, кожаный свиток и нескольких других папирусов и табличек.
Они позволяют решать задачи, например, строительства или деления продуктов на много человек или что-нибудь в этом роде. Это не глубокая математика. То, что я знаю, может быть, есть еще какая-то. И я хочу сказать, что то, что мы знаем про эту математику, мне кажется, не отражает знания нашего о математических знаниях тех, кто строил пирамиды.
All these sources date back to the time of the Middle Kingdom, the 20th and 17th centuries BC. Nevertheless, modern scientists can't deny the existence of the copies of the more ancient sources. Thanks to them, we know that the Egyptians were able to calculate the surface and volume of various geometric shapes. Interestingly enough, in order to calculate the area of a circle, they squared 8/9 of its diameter. Thus, it's clear that the Egyptians knew about the value of pi. However, they used only its approximate value of 3/16. This is much more accurate than the value of 3, which was used by the Chinese, or even Vitruvius, which was also present in the Talmud. Only in the ancient period in the 3rd century BC was Archimedes able to improve this value and get pi equals 22/7. In order to understand how the ancient architects were able to calculate such exact values, let's figure out their measurement standards first. The main units of measurement in Egypt were the width of a finger, the width of 4 fingers, i.e. the palm, 6 palms placed down along the arm called a short cubit, and 7 palms, a royal cubit. A royal cubit consisted of 7 palms or 28 fingers and was equal to 52.3 centimeters. It is believed that the ancient Egyptians measured long distances with a measuring rope where each cubit was marked with a knot. We do not know, however, how they could have achieved such accuracy as, for example, the Pyramid of Cheops, where the difference between the sides varies between 20 to 4 centimeters, depending on the source of information, while the side length is 230 meters. Could it have been achieved with a rope? More than 20 cubit rods have been found on the territory of Egypt, but almost all of them date back to the late period of the New Kingdom, 15th to 10th centuries BC. These rods help to determine the average cubit length. The rods, made of wood or stone, are considered to be the symbol of status of an architect wielding the tool. Doesn't it seem strange that no more accurate standards for measuring length have ever been found since the era of the Great Pyramid's construction? Today, any guidebook tells us that the measurements of the Great Pyramid are mathematically outstanding, with the perimeter of the base accurately equal to the length of the circle, the radius of which equals to the height of the pyramid. This suggests that the builders had already been familiar with the modern value of pi. It turns out that this value is closer to pi than its estimate, according to the previously mentioned Rhind Mathematical Papyrus. And the ratio of the lateral face apothem to the half-length of the base side equals to the number of Phidias, the so-called golden ratio, where golden ratio constant equals 1.62. The golden ratio is a special number found by dividing a straight segment into 2 parts, so that the longer part divided by the smaller part is also equal to the whole length divided by the longer part. This ratio is called by many the divine proportion and can be found in almost anything around us: nature, human body, art, etc.
Однако, беспристрастность нашего исследования требует отметить и другую особенность. Эти математические свойства в таком виде обнаруживаются только у пирамиды Хеопса, а у 2 соседних пирамид на плато Гиза, или у пирамид Дашура или Мейдума, они не наблюдаются. И чтобы понять, насколько важно было для древних зодчих придерживаться точности при строительстве, нам стоит обратиться к работе Флиндерса Петри, который одним из первых обратил внимание на мастерство древних строителей.
In the book, The Pyramids and Temples of Giza, Flinders Petrie provides absolutely amazing examples of their craftsmanship. While measuring the remaining northern casing stones of the Great Pyramid, he discovered that the average deviation for cutting stone from a straight line and a true rectangle is only 0.25 millimeters, with a total length of 190.5 centimeters. The deviation from a straight line of the descending passage, which is cut deep into the pyramid into the bedrock 105.3 meters long, is only 6.4 millimeters. To achieve this accuracy, the ancients had to possess some appropriate measuring instruments as well as the knowledge of metrology, the study of measurement, and wielding the measuring instruments. This science appeared only at the beginning of the Industrial Revolution in the 18th century, when the need for certain standards and precise measuring instruments became essential. As a rule, while measuring an object, one should choose a measurement instrument with no more than 10% tolerance. However, the accuracy achieved by the builders of the Great Pyramid is equal to modern standards. For instance, the tolerance of 2 millimeters with a total length of 2 meters can be observed in the completed concrete and reinforced concrete structures of our time. The accuracy of the Egyptian pyramids alignment according to the cardinal points is no exception either. For example, the bent pyramid has the northern deviation of 17 minutes, while the neighboring red pyramid 8 minutes. The greatest example, though, is the Great Pyramid with a deviation of just 3 minutes.
Совершенно простой вопрос, осмысленный, который можно задать любому. Я хочу взять направление на север, на полярную звезду, там на что хотите, для того, чтобы построить сооружение со стороной 200 метров. Если хорошо себе представить 200 метров, это 22 футбольных поля. Подряд, если положить 2 футбольных поля, это будет 200 метров. Теперь я хочу точно направить это на север. Для того, чтобы это сделать, я хочу, нормально, я могу там глазом посмотреть, прикинуть, сколько это будет. Как это делается? Вешка здесь и вешка там. Теперь я могу совместить эти две вешки, посмотреть, какой у них будет угловой размер, какой это будет. Теперь я могу сделать следующее. Возьму, скатаю там трубу из папируса сверну, натяну волосок. Оставшийся волосок натяну там, поставлю. Будет у меня визир такой. И туда буду смотреть. Тоже будет угловой размер. Так вот, этого углового размера недостаточно, чтобы обеспечить ту точность, которую достигли египтяне на строительстве пирамиды. Вот этого волоска, если они пользовались волоском, не хватит по точности. Потому что у них 3 сантиметра на 200 метрах. И может любой оценить. Попробовать. Поэтому вопрос, как они это делали? А второй вопрос, если уж они это делали, зачем? И тут, извините меня, конечно, уважаемые археологи, культурологи, исследователи культуры Египта, я, к сожалению, не могу согласиться с тем, что это нужно было для того, чтобы построить храм для почитания богов.
I hope you enjoyed this video and learned something new and interesting. Please subscribe to my channel, like this video, and leave your comments below.